Welcome to the technical video of our DSE3101 project. Our video comprises of 4 components: data sourcing and processing, vulnerability modeling, connectivity modeling, and future implementations. Our interface has 2 key features: a vulnerability tab that displays the vulnerabilities of MRT stations in Singapore, with the top 5 most vulnerable stations highlighted in red. Selecting a particular setting on the right side panel changes the time of day and the type of day. A connectivity tab displays the connectivity scores of stations, with the bottom 5 least connected stations highlighted in red. Selecting a particular station provides a list of other reachable MRT stations via means of walking or bus services. To gather the necessary data for our project, we utilize a wide variety of sources. This ranges from web scraping conventional sites like Wikipedia and open source government APIs like LTA Data Mall, data.gov, and OneMap. Less conventional sources involve gathering data from a Telegram bot called SG-MRT Updates and property review websites. For the scope of our project, we define a breakdown event as one with travel delays of 30 minutes or more. Historical train breakdown notices have been web scraped from SMRT's official X account. This includes notices from April 2017 to April 2025. We employed natural language processing techniques to identify relevant breakdown events. These NLP techniques include sentiment analysis, fuzzy matching, and bag of words. These are some of the words most used to identify breakdown events. In our modeling, we tested 5 methods: linear regression, logistic regression, naive Bayes, random forest, and extreme gradient boosting. Of all the fitted models, we found that XGBoost worked best with our sparse data structure and violated the least statistical assumptions. Our connectivity metric is based on direct and indirect connection methods. The scoring formula as follows. Firstly, an indicator variable representing whether a station is an interchange is multiplied by the number of operating lines not affected by the breakdown. This is assigned the highest weight as it is a convenient and efficient way to commute. Next, a walkable station has been defined as one reachable within 15 minutes or less of walking time. A log scale has been used to penalize for longer walking times. A lower weight has been assigned to this factor to account for individuals with mobility issues. Finally, we take the sum of the total number of bus services at each bus stop surrounding the MRT station. We use a log scale to penalize the increase in score as the number of bus services between 2 MRT stations increase. A moderate weight is used as it is not as convenient as a direct transfer, but is more accommodating for individuals with mobility issues. Future implementations of our project extend to a predictive algorithm. This could help predict the vulnerabilities for future MRT lines such as the Jurong Regional Line and the Cross Island Line. For connectivity, we can incorporate connectivity indexes that link MRT stations to key hubs like schools and offices. We also intend to create pipelines to update data real-time. Thank you.